So, okay, so we'll start. Welcome all. Welcome to the seventh week of discussion session of the course Finite Element Method course offered by NPTEL. The course instructor of this course is Professor Biswanath Banerjee and Professor Amit Shah, and I am your teaching assistant. Myself, Asif Raza. I am a PhD scholar from Department of Civil Engineering, IC Bangalore. So today we'll be discussing questions relevant to assignment number 7, as well as we'll discuss the solution of assignment 7 as well. Before that, we'll inform others that in the last week me and Rafael worked on the code of Beam FEM in conversion of MATLAB or as well as Octave code. So you can go through that. That has been uploaded. So let's begin today's session. So first question is, let a polynomial approximation of a field for a field variable in FEM is given by this fxy equal to c0 plus c1x plus c2y plus c3xy plus c4x square y plus c5y square plus c6y cube, where x and y are the coordinate, ci are the constant. The polynomial is complete up to degree and the options are 0, 1, 2, 3. So answers, what do you think? What will be the answers? Okay, so Rafael has said the option B, as well as Abraham has said option B. So yeah, the answer is option B. So can anyone elaborate how do you think, why do you think it's option B, why not option C, D? Can any one of you? Maybe Jess this time? Yeah.
Yeah, the degree one it is complete. There is x and y. For for degree two, there
Yeah.
should be uh, x square and y square and
Yeah. Y
no,
square is there, xy is also there.
but x square is not.
Yes. So to get the degree 2 complete, we need to have constant term with x square. This is missing to have degree 2 as a complete, right? And what if I ask you, like, for degree 3, what should be, what all polynomials should be there?
X cube, y cube, x square y, x y square,
X cube, y cube, x
x
square, y.
square y, x y square.
Yeah. So out of this, we have two, we are missing two, other two. Like x cube, we are missing, and uh, x square, y we have, and this one we are missing. So since degree 2 itself is incomplete, so we won't go beyond that. So answer is option B only. Okay. So similar question you had in the assignment, I'll just ask that thing in the continuation of this. So this was the question in the assignment. Suppose a polynomial approximation for a field variable in FEM is given by this function c0 plus c1x plus c2y plus c3x square plus c4xy plus c5y square plus c6x cube xy square and y cube, where x and y are the coordinates and ci are the constant. The polynomial is complete up to degree. So answer to this question was, yeah.
Degree
So
two.
yes. So in this, for degree 3, what is missing? X square y term, right? Okay. So now let's move on back to the question. Next question. So this is second question. Suppose in a finite element discretization, global continuity is C2 if phi is global shape function and its first and second derivative are phi prime and phi double prime respectively. Choose the correct option. First option is only phi is inter-element continuous. Second option is only phi prime is inter-element continuous. Third option is all the three phi prime, phi double prime, all are inter-element continuous. And the fourth option is phi and phi prime are inter-element continuous, but phi double prime is inter-element discontinuous. So, what do you think? What will be the correct answer? Uh, Question says global continuity is C2 and phi is my global state function. Not even guesses. Rafael is saying option C. What about this? Jace? Not sure. Okay. Okay, I'll elaborate in this thing. Mm. So the question says we have global continuity of C2. C2. And my function is phi. So C2 implies what? C2 implies its first derivative and its second derivative all are continuous. It implies this one. This C2 implies, or in general sense, if I write, Cn implies uh, the function and its uh, derivatives its derivative uh, up to nth all are continuous. So if my function global my function is phi, right? So phi is c2, it implies what? Phi is according to the above statement, phi will be continuous throughout the domain. Phi prime will be continuous and phi double prime will be continuous. So all the three are continuous throughout the domain. So as a result, our correct answer would be option C. I hope this is clear. Uh, Jess, if you can ask, like, what is the thing you are not understanding in this? Okay, clear. Yeah, Rafael wants to add something here.
In this question,
Yeah.
this question asks about inter-element continuous and inter-element discontinuous thing. But what if I believe there exist questions about continuity between element? You know, when uh, inter-element
Okay.
continuity is
Okay. So
presenting, but
there are two things. The question yes says about inter-element continuity. See, everywhere it's written inter-element continuity, but somewhere like there is a possibility that function, suppose these are two elements. A function is continuous for a particular element. It's continuous within the element, but it's not continuous for a different element. Like there is a jump, right, for a particular function. I'm saying, let's say this is I for first element for second function. Second element. So what do we say that this function is continuous in intra element, right, but discontinuous in inter element, isn't it? This is what you wanted to say, Rafael, is it?
Yes. How you say that intra element and inter element? Yes, inter.
Inter means completely different, and intra means within the same element. It's just an English thing. Intra element. It implies within the element, and inter element. So this implies uh, continuity at the boundaries of that element, like continuities at the boundaries of element. So in this inter element, we will compare with an inter element thing. Suppose at the first element boundary we have some function, and the second element boundary we have some function. So the ending and the starting, that value should be same to have the continuity to be maintained. Okay. In light with this similar question as asked in the assignment, I'll just go into that thing. Yeah. So I hope what I said now has made something, gave something clarification. So this was the question in your assignment. Question was, uh, suppose in a finite element discretization, phi is global safe function and its first and second order derivative, phi prime and phi double prime respectively, if the global continuity is C naught here. See, earlier the question was C2, which I asked earlier, it was C2, here it's C naught. So if I don't show you the options, like if I'll just remove it, and my function is C naught, right? Phi is C naught. So what do you think? What will be the answer? Anyone can raise? Yeah.
Yeah, phi not C0 continuity means that it is continuous, but all derivatives are discontinuous.
Yeah. So C naught implies that phi is continuous, but phi phi prime won't be continuous as it is not C1, right? So the correct statement will be that phi is interelement continuous while phi prime and phi double prime will not be, right? So answer would be option A. Yeah, the answer would be option A. Phi is interelement continuous, but phi prime and phi double prime are interelement continuous. Okay, I hope Abdullah said only primary variable is continuous. Okay.
It's interesting here that we are saying about global shape function, but in finite element method we only know element shape function,
No,
or
but
we also know global shape function.
yeah, those shape functions can be defined for different elements respectively. Like that function, uh, that can be specified with a domain thing, right? For first element, that global shape function will have a different definition. For the second element, it may have a different definition. I'm saying kind of suppose suppose mod x function. Mod x function has like this graph, right? So what do we say? Mod x is equal to x if x is greater than 0, and minus x if x is less than 0, right? So this has some domain thing, that's what I'm saying. Similarly, so globally we are writing like this. Locally it's
Domain here is the whole body with its boundary, right?
yeah.
Uh,
So
I mean,
for a finite element thing, if like my phi is my global shape function. So it may have a different definition for element 1, different definition for element 2. I meant it like this.
Okay, okay, right. Okay.
Okay, I hope this is clear now. Okay, let's move on to the next question. Yeah, so question is, in case of CST element, CST is constant strain triangle element, what will be the correct option? First option is both displacement and strain are constant within the element. Second is only strain is constant but displacement varies within the element. Third is only displacement is constant but strain varies within the element. And fourth is both displacement and strain varies within the element. And yeah, all of the audience has said option B. Okay, so can anyone elaborate on this? If I may ask, why do you think why strain is constant but displacement varies? Yeah, Rafael, you may go.
In constant strain element, the function for element is linear, so definitely displacement will be linear, and varies within the element, but derivative of it's constant. So
Yes,
strain is constant.
yes. So you are also correct, and Abdullah has also said the same thing in this chat also. So yeah, both of them are correct. So strain is represented in terms of the derivative of the displacement. So displacement is represented in a linear sense. When we take the derivative, we'll get a constant. So strain will be constant and displacement has a linear uh, form. So yeah. Okay. So move on to the next question. We'll come back to this question later. First, do this. So consider a 9-node quadratic Lagrange element in natural coordinate system and answer the following question from 6 to 7. So what is the safe function of node 2? So okay, what do you think? What will be the answer? Without actually solving, can you like pick from the option itself? Like what will be the correct answer? Without actually solving, uh, by using elimination rule, can you guys solve? Anyone has idea? Rafael, yeah, Rafael, you may.
If we are checking this without by guessing, we just need to put coordinates of the node to the functions, and we need to obtain one value
Yeah.
for coordinates theta is equal to -2, xi is equal to 0, and for the rest coordinates we should have 0.
So, what's your xi and eta coordinate value for node 2?
Zeta is equal to 0, eta is equal to -1.
Yeah. So, let's try and substitute these values in all of the option and try to get what will be the answer. So, if we substitute z uh, xi and eta equal to 0 and -1 in the option A, it will give me 0. Like xi itself is 0, this will also give me 0, and this will also give me 0. So we are able to eliminate itself from the option itself. And let's confirm, what if we substitute xi and eta equal to 0 comma -1 to the option C. So this will give me 1, and 1 by 2, this will be answer will be 1, and this will be 1 plus 1, this will be 2. So 2 by 2, this will be 1. So correct answer is option C. So this way we can directly say this is the correct answer. Now going through the traditional way how to write the safe function, like, okay, yeah, Rafal.
If we want to derive this formula, we just need to notice that uh, when zeta is equal to -1 and 1, it should be 0. And
Uh,
also when zeta is,
yeah,
sorry,
can you repeat once again?
uh, if we want to derive this C formula,
Yeah.
the easiest way for me personally, it's to notice that um, for zeta is equal to -1 and 1, it should be 0. Our function should be 0 for the node 2. So in our function we should have 1 minus zeta and 1 plus zeta is equal to 0. So it gives our 1 minus zeta squared term in our shape function. After that, we are noticing that for
Uh,
eta is equal to
yeah, you're
1
saying
and
zeta as this xi, right?
xi. Oh, sorry, xi.
Yeah.
Sorry,
Okay.
xi.
Yeah.
And after that, we are noticing that eta is equal to 0. For eta is equal to 0, if for eta is equal to 1, we also have we also should have 0,
Yeah.
because nodes 4, 5, 6, and nodes 7, 8, 9 are on the line eta is equal to 0 and eta is equal to 1 respectively.
Yeah.
So we should have 0 there. For eta is equal to 1, we need to have 1 minus eta term. And
Yeah.
for eta is equal to 0, we should have eta, just eta term. And we see that it is the second bracket in our question. After that, we just check in condition that at the node 2 is equal to 0, it should be equal to 1, and we are deriving this formula for constant 1
Yeah.
half.
Okay. So 1, 2, 3, 4. Numbering is not correct. 4, 5, 6. Okay. So let me elaborate it further. 7, 8, 9. Yeah. So you are correct. I'll just elaborate it further. Yeah, so what I learned from my teachers is for a Lagrangian element, how to find a simple way the safe function is, first of all, if you are given the option, this is like a very easy thing, just to substitute the values, and if you are getting value 1, it's just a guess thing. Now solving for it, see, we want to find the safe function for node 2, right, and 2 or 5 2, whatever. So what we can do is, I'll just pick another color. See, okay. So leaving 2, we'll just draw lines here, 1, 2, 3, and 4. Okay, so this line is with respect to z equal to -1, this is with respect to z equal to +1, then this is eta equal to 0, and this is eta equal to 1, right? So in these lines, n2 would be what? It will be equal to 0. In any of these I eta values along this line, uh, the value of n2 would be 0. So n2 can be written now using this lines itself. So first using this one, so this would be what? Xi plus 1, this is xi minus 1, this is eta minus 0, and last one eta minus 1. Now substitute the value of xi in the same thing. So xi value, xi and eta value for node 2 is 0 comma minus 1. right?
Multiplied by constant.
No, that will come out naturally. That's what I'm saying. You just see. So this will be uh, 0 plus 1, then 0 minus 1, and uh, eta is minus 1, uh, minus 0, and minus 1, minus 1. So what we'll have now here is xi plus 1, xi minus 1, eta, eta minus 1, and this is minus 1, this is minus 1, minus 1, this will give me plus 1, and this is minus 2, right? So finally we can write xi square minus 1, eta minus 1, minus 2, again multiplying both, taking minus on the above, so n2 would be equal to what? If I take minus outside, this will be 1 minus xi square. Eta can be multiplied inside, eta square minus eta, and 2. So this comes out naturally now. I hope this is alright now. So this is the same answer as what we got earlier. See? Uh, see, okay, one other way we can think of, you must have studied in the earlier classes, uh, in the numerical approximation or something like that. There you must have studied something like x minus xa, or
It looks like we are deriving Lagrange polynomial for
yes, that's what I want to
two
say.
dimension.
Yeah. So earlier you guys must have studied like this: x naught minus x1, x naught minus x2, x naught minus x3, x naught minus x4. Right? This way you guys must have studied Lagrange polynomials, right? This was the way how to derive it. So similarly, this is the thing. I hope this is giving you some new insights how to find the safe function. Okay. Now let's move on to the second question. Next question. The safe function of node 5 is. So let's try first using that elimination thing. Then again we can think of how to solve this using this way, what I was trying to do. So we want to find at node 5 safe function of node 5. The safe function of node 5 has a coordinate of xi eta as what? 0 comma 0, right? So 0 comma 0, when I substitute 0 0 in all the option, we get 1 here, 1 over here, 0 0 here. So we have like two options. So this way we cannot like directly eliminate the solutions, but still we are closer. Like out of these two options we can say something that this is like one of the two will be the answer. Okay. Yeah, Abdullah is saying option B. Yeah, I hope that it will be option B only, but let's do this the traditional way now. Okay. So okay. One more thing you can check, like without doing further calculation, you can also think of why option B will be the correct answer. So anyone can guess?
Actually, I substitute the node 1, 1 in A and B, and I noted that B is the correct one.
Uh, I didn't get you. Can you repeat once again?
Yes, actually, we need the shape function to be 0 at all other nodes, like at
Yeah,
node
yeah, yeah.
number
Yes, yes,
when
yes.
psi is 1 and eta is 1. So I
Yes.
substituted 1. That's
Yes. That's what I wanted to say. That for this will be a value of 1 at the same node. Like node 5, this value will give me the value 1. But at other nodes, this safe function value should give me value equal to 0. So when we substitute this, say you are saying node 1 is having minus 1 comma minus 1, right? So node 1 is having minus 1 comma minus 1. So if we substitute the same functions to what will be the value of n5 at node 1, that should be 0, and node say function of node at node 5, that should be 1. So let's see. So if we substitute xi and eta equal to minus 1 comma minus 1 in option A, it will be what? 1 1 plus that is, this will be 1 and this will also be 1, that will give me 4. That is incorrect. And option B, that will be like 1 and this will be minus 1 and this will be also minus 1. So this will give me 0. So again we can see for when we substitute value of xi eta value of node 1, so the value of say function at node 1, this value should come out to be 0, but for this it came out to be 4, this came out to be 0. So this thing matches now. So we can now say for sure that this will be my correct answer. Rafael has written something. A has no real roots, non-example for safe functions. Okay, that is also one thing. Okay, now let's do this the more traditional way, like which I was trying to say. Yeah, so we have the element as this: 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 9. 8. So we need to find the safe function at node 5. So we'll pass on we'll draw lines, uh, all the lines except passing from node 5. So one line could be like this, one line could be like this, one line could be like this, and one line could be like this. So this is like z equal to minus 1, this is z equal to 1, eta equal to minus 1, and eta equal to 1. Okay, we have to cover all the nodes by drawing these lines. So now the value of n5 can be written like so. This line, this is I plus 1, this one I minus 1, again eta plus 1 and eta minus 1 upon. So the values of sin eta for node 5 is 0 comma 0. So 0 plus 1, 0 minus 1, 0 plus 1 and 0 minus 1. This will give me what? Eta plus 1, eta minus 1, that will be like eta square minus 1, and this will be eta square minus 1, and this is at the top minus 1 times minus 1, so that will be 1, and we can also write it like 1 minus xi square, 1 minus eta square upon. So there is no need of 1. Okay, so I think that matches. Yeah, I hope nobody has doubt. Okay, so let's move on. Let's do the similar thing. Yeah. So this was in your assignment. Identify the correct option for given elements. Figure A has 8 nodes, figure B has 9 nodes. So options are uh, figure A is 8 node Lagrange element and figure B is 9 node Lagrange element. Figure A is serendipity and figure B is Lagrange. Figure A is serendipity and figure B is also a serendipity element. And fourth statement says uh, Lagrange and serendipity. So all of them has given an option B. So yeah, everyone is correct. Answer is option B itself. So in this, I don't know much about it, but can anybody throw some light why it's called a serendipity element and why not a Lagrange element? Like figure A is called as 8 node serendipity element, not a 8 node Lagrange element. Why is it so?
I believe it's because Lagrange formulation. No, first of all, we say that we need to have uh, Lagrange polynomial. We need to have full polynomial, right? We say at first that we have all terms in our polynomial
Yeah, complete.
description model, complete polynomial, yes. But now we have a computational cost with this. For instance, this B element is very cost from computational point of view. It has a lot of nodes, and as I understood that history of that uh, for for boundary elements, we need to have more points on the boundary of the element for some problems. I said that I understand this like this. The serendipity element solve this task because a lot of elements presented on the boundary, and serendipity is because how we formulate shape functions, I believe, by guessing.
Okay. Abdullah, can you just unmute yourself and try to elaborate what you want to say? Because you're saying inner nodes present for Lagrange and the serendipity depends on no nodes inside element for simplification.
I believe also that the serendipity is because we are broken the rules of that all polynomials should be
I,
full. At the same time, with that, we are working with serendipity element and solving our tasks.
Okay, okay. Let's Abdullah also join in this discussion. Yeah, Abdullah, can you?
yeah, as I understood from the serendipity is a method that depends on simplification and just try to generate the shape function from looking to the element itself. So we delete the inside elements and we try to, as we just did before, this function when we were generating the shape function, it's depending on the serendipity that we make the condition that suits our shape function and the node, and we make it.
Okay. Uh, these are like more deep thoughts. What I know, like the most simplified way is the Lagrange element. Why do we call it as a Lagrange element? We can simply use the Lagrange interpolation functions. Just use the Lagrange interpolation function to find the safe function, like I did earlier for earlier. So uh, uh, and one more thing is the thing which you guys are also throwing some light on, that the complete sense, the sense of completeness is being brought up by Lagrange element. So if you see this element, this Lagrange element, so there is not a special focus or more like on xi or eta. If you see at this, suppose if it is a quadratic variation, suppose, so it is along this line there is a quadratic variation. If I say, yeah, okay, along this line there would also be a quadratic variation, along this line there would also be a quadratic variation. But if I consider this element, there is a quadratic variation along this element, there is a quadratic variation along this element, along this line. What about here? What will you say? What kind of variation will be there from 4 to 5? Seeing the element will see it's a linear thing. So for Lagrange element, you see from everywhere it will be kind of a similar thing. So one way to see is that, another is the Lagrange interpolation function, which I told you. Like we can directly use Lagrange interpolation function to find the safe function. Like I solved for this n5 or for n2 in this example, we can just directly use this Lagrange interpolation functions to find the safe function. Okay, now let's move on to shall we? Okay, let's solve the previous questions. Okay, let's solve this question. Consider a 3-node CST element, constant strength triangle element, and answer the following question number from 4 to 5. Consider displacement at any point within the element as this, and strain along x direction as this. So we are given with the element like this. In the assignment, you were given a more simplified element. It was a right angled triangle, but let it be the question in this is a general sense. So the question is, what will be the displacement at point P located within the element? So I don't think we can directly solve it, so it's better to it step by step. So for a CST element, what do we use our safe function as a0 plus a1x plus a2y, right? So for if I say node 1 has the value of displacement u as u1, this as u2, and this as u3. So u1 will have the value as a0 plus a1 x1 plus a2 y1. Similarly u2, a0 plus a1 x2 plus a2 y2, u3 as a0 plus a1 x3 a2 y3, where x1 x2 x1 y1 x2 y2 x3 y3 are the coordinates of the node 1 2 3 respectively. Okay, so in our case okay, let it be like this as of now. So this will be, we can write it like this: u1 u2 u3 is equal to 1 x1 y1 1 x2 y2 1 x3 y3 times a0 a1 a2. We can write like this. Now we want to find the value of u at point P, right? So if for node P we have the value of x and y, we just need the value of a0, a1 and a2, then we'll get the value of this displacement value at node point P. To find value of a0, a1 and a2, we can use this above and we can write as a0, a1, a2 as 1 1 1 x1 x2 x3 y1 y2 y3 inverse u1, u2, u3. Okay, so let's use this. So in our case, what is the matrix here? 1 1 x1 y1. So x1 y1 is 2 comma 7, so this is 2 7. x2 y2 is 5 comma 3, so this is 5 and 3. And x3 y3 is 7 comma 10. You need to find the inverse and u1 u2 u3. Okay, so a0 a1 a2. I need to find the inverse of this, right? So okay, so I have opened a MATLAB. I'll just show you guys. Just a minute. Sorry guys for the interruption. Now we're back. Just okay. So the inverse gave me this solution. Now let's say if I write this thing as equation 1, so we substitute this in equation 1, substitute before that, so equation 1 can be written as take this as equation 2, so that can be written as u of x comma y as, so see, that can be written as 1 x y a0 a1 and a2. So this way we just substitute the value of a1 and a2 here and we'll get the form of u. So u of x comma y will be 1 x y 1 1 minus 1 minus 0.2414 0.1034 0.1379 0.0690 minus 0.1724 and this is 0.1034 u1 u2 u3. Okay, so this is what we'll have. And okay, so I'll just write it here. So this will give me, I'll just sort in the MATLAB. So now, so multiplying this two, we'll have, let's say, n1, n2, n3 times u1, u2, u3. According to our question, it's phi I, so better I write it as phi 1, phi 2, phi 3. Okay, so phi 1 will be equal to what? We just need to find phi 1, phi 2, phi 3. So I'll just directly use the multiplication. So this is or I can write it as the transpose is equal to 1 minus 0.2414x plus 0.0690y. This will be 1 plus 0.1034x minus 0.1724y, and this will be minus 1 plus 0.1379x plus 0.1034y. Okay, so now I've got the values of phi 1, phi 2, phi 3. So according to the question, we have been given the value of u as phi 1 u1 plus phi 2 u2 plus phi 3 u3, right? To find the value of u at p, we just need to substitute phi 1 at p u1, phi 2 at p u2, and phi 3 at p u3, right? And this will be equal to, so the coordinates of p we have as 4, 6. 4, 6. So phi 1 value will be 1 minus 0.2414 times 4 plus 0.0690 times 6. This will be u1 plus 1 plus 0.1034x minus 0.1724 times 6 u2 plus minus 1 plus 0.1379 times, okay, this is 4 plus 0.1034 times 6 u3. Okay, so finally up will be equal to what? So values will be equal to, just find, let us find these values. So we have 1 minus 0.2414 times 4 plus 0.069 times 6. So this is equal to 0.4484 u1. I'll just write this thing with a different notation, different color, and this is 1 plus 0.1034 times 4 minus 0.1724 times 6. This is 0.3792 times u2 plus we have minus 1 plus 0.1379 times 4 plus 0.1034 times 6. This is 0.172, yeah, times u3. So let's see what do we have any answers closer to this. So 0.4484, 0.4484, this one, 0.379 u2, 0.172 u3. Yeah, so This is my answer. Hope nobody has doubt. So we just know the values of phi 1 here. You can see we have the values of phi 1 and the expression of u, and we can just substitute the value of x and y uh, for whatever, like for any point within the element which we want to find the displacement value in this equation. So we'll get the expression for the displacement. Now to solve uh, part second part or question number 5, we need to find the strain at this point located within the element. This is already given in the question that we to find the strain we use this, right? So as we already have phi, we just need to find the derivatives of phi I, right? So we have phi I. We need to find the derivatives of phi I and derivatives of phi I with respect to x only, not with respect to y, with respect to x only, because we are finding this strain only along x direction. So now to solve this, uh, let us first write this thing. Let's see if I can copy. Okay, so we have phi I here like this. Now derivatives of phi I, that implies del phi 1 by del x, del phi 2 by del x, and del phi 3 by del x. What will be equal? What will be this? This will be del phi 1 by del x, is you just see here. So this will equal to minus 2414, right? Del phi 2 by del x here only, so this is 0.1034, and del phi 3 by del x is this, so 0.1379, right? So as given in the question, that the x is equal to summation del phi I by del xi ui, sorry, del x ui I equal to 1 to 3. That implies del phi 1 by del x u1 plus del phi 2 by del x u2 plus del phi 3 by del x u3, and we have the values as minus 0.2414 u1 plus 0.1034 u2 plus 0.1379 u3. So this is my answer. So epsilon here we didn't substitute specifically for uh, like for a particular coordinate. We didn't substitute x equal to something like that. So this epsilon xx is constant throughout this element. That's why it's called as CST, constant strain triangle, right? So with this, our answer is matching with option D. Okay. Does anybody have any doubt, or should I move on to the next question now? I hope nobody has doubt. If any, you can say. Yeah, Rafael, you want to say something?
I wonder why we're still working with coordinates of physical element. if finite element method suggests that we are mapping it to some master element, or so.
That's see, this is the more basic thing. What we are saying, this is the more the basic thing. Why you need to understand why do we need to go for master element or slave element? You need to understand that that is for our
No. I believe that we're delaying by some reason the mapping to master element. I don't know why, but in triangular element, uh, I believe it is more suitable to use to work with master element.
no. That
And
is for like rectangular element itself. We can just use a four-noted square element to solve for a quadrilateral also. This is like just a conceptual thing which we are doing. This is not the actual computation or necessarily the problem which we are solving. This is just to understand how actually we are trying to find. Master element need came for the integration, the integration which we do to get the stiffness matrix, and then we assemble it to simplify that. That's why we came up with master and slave element thing, and consequently there is a parametric, or you may say isoparametric formulation is also there. I hope I'm not wrong.
okay, I guess that in exam we need to do a manipulation to find it. An exam we will need to find this matrix, inverse matrix by head.
Yeah,
But
see, if you use master element or slave element, you can go for it because in reality, uh, in the exam, you will just be needed to give this answer, right? So if you solve this using slave element, uh, master elements, then it's your call because the computation. If that makes more simplification for you, that's more makes you more easy for you, then go for it. Nobody will stop you. There is a thing, Jacobian thing. Uh, what is master and slave element? Okay. Abdullah is asking what is master and slave element. See, okay. I say. So the problem in consideration which I asked right now was like this. This is node 1, 2, 3, and our coordinate system was like this, x and y. Uh, okay, so this could be like uh, in a general body, this could be different elements altogether having different coordinates like this. It goes on like so. This is like first element, second element, third element, fourth element, fifth element, sixth element, seventh element. Okay, goes on. We can have one master element like this uh, with a xi and eta coordinate system such that uh, it can be used to map each element having different what notation should I use? Psi. So psi one maps a master element to the this. So master element is this having like xi and eta as 0 0. This is 1 comma 0 and this is 0 comma 1. Okay, as you have studied in the uh, uh, four noded square element where you took xi eta starting from -1. This was having like -1 comma 1. This was having 1 comma -1. This was 1 comma 1, and this was -1 comma 1, right? Similarly, in the triangle, there is so this is kind of a master element for the elements having quadrilateral in the general body. Similarly, for triangular, this can be said as a master element, and these are all the slave elements which I am talking about. Slave elements are the actual elements present in the body. So master element can be used for our simplified calculation. Okay, uh, what mm, I don't know if you guys have studied this. Okay.
Can I share my screen?
Yeah, go for it. Just a minute. One thing.
And yes, you will see this, and you can explain from my screen because it's already written there.
Okay, okay. Save it then. I'll just stop sharing mine.
Here.
Yeah.
You say master element and physical. I heard master definition the following: physical element, master element.
Yeah. So
In the lecture 7 says that we have physical element and parent element. So Amit Show says that master is parent element.
yes, yes, yes.
So, and you say that physical is slave element, and this is a master element.
Master element. Yeah. So just the naming thing, which is like
Yes,
in
yes,
in line with what I am trying to say.
yes. Abdullah just if Abdullah saw all lectures of the week 7, he knows that it is a parent element, not master element. I
Okay,
just
okay.
call it master element.
Yeah. So master element is my parent element, and the slave element, which I'm saying, is the actual element or the physical element which are present in the system. So okay. Thanks for the clarification, Rafael.
I wanted to say to Abdullah what is master element, and you say you wanted to show
Yeah.
the
This.
KEG. Do you see the Abdullah?
Yes,
Do you
yes.
see this KEG for element? It is an integration of
Yeah.
our functions.
Yes, yes, but on which video is this? I don't think we have.
No, it's from another course. It is not from our course. I just share information where with me. It is
Uh-huh.
not from our course. Another course. I can send
Okay.
you the lecture. I can send you the link to this YouTube lecture. Now I want to show why we need this master element. As you can see here, we have an integration step of the domain.
Yeah.
Do you see this integration step?
Yeah,
KEG,
yeah.
it is the integration step. And infinite element method, we are not doing integration for the physical element because it's too hard. A lot of coordinates there. We just collect all information about nodes in physical element and map it to the easy master element.
Got it, got it. You mean the master element is the element with the parametric axis?
Yes, this master element, you can see it is very easy. Along the we can easily integrate this function in master element,
Understood,
and,
understood.
and there exists way to integrating this. So all physical elements will be mapped into master element, and
Yes, yes,
integration
I
will be
think.
procedure of integration will be the same for all physical elements. So I asked the question because I believe that finding this function is easily in master element was because it's too difficult to invert matrix on the exam. We have only 3 hours for exam. It will be time consuming to invert matrix with bad numbers, as you can imagine.
I think I got it.
Okay, so I think I cannot take over.
Okay, I close my screen.
Yeah, I'll just start sharing mine.
The problem will be that our elements, I believe, some elements will be not. For instance, if some element will be very deformed, it will be close to line, and there's some issues there. I believe we consider it later. So some triangular element can be after deformation. It can be not triangular at all.
Yeah, so the use of the master element is that the integration can be done quite easily. So if you see, the xi will vary from what 0 to 1 and eta will vary from 0 to 1. And when we use the numerical integration scheme or that quadrature rule, again it becomes more simplified. So this is quite an easy, like quite is important thing, which is okay. I hope so. Jace also asked like master element has natural. Is it right to say so? So yeah, we can say so that master element has a natural coordinate system, and the Jacobian. So if I may say, so this master element to the element one or element two, element three, element four successively will have a different Jacobian values. There could be what I mean to say is what Raphael was also saying, the master element has this kind of 0 0 0 1 0 0 1 say, and different element has different area. So say this is element 1, element 2, element 3, element 4 uh, has a linear map attached to all of this. So Jacobian to all these elements, say J1, J2, J3, I'll just write it in Roman numeral, J1, J2, J3, J4. They might be equal, but in generally we can say they are not equal. If all the elements have an equal area, then there is a possibility that J1, J2, J3, J4, etc. will be equal. Okay. Now let's move on to further questions. Okay, so this is eighth question. Question number 8 is let there be 8 node serendipity element if the shape function at node 4 and node 8 are phi 4 and phi 8 respectively. The ratio of them, that is phi 4 upon phi 8 is, I'll just magnify this. You guys can say what will be my answer. So we are finding the ratio of phi 4 by phi 8. The answer, can you guys, what will be the answer? Uh, okay, rather asking what is the answer, I'll just go step by step. What will be phi 4? Say function of phi 4. That will be equal to, we'll just draw 3 lines in this case. and this will give me 1 plus xi 1 minus xi, sorry, I'm saying xi eta, and 1 plus eta upon, so this will be equal to psi is
Why we're not including y minus one? Oh, sorry, that's okay.
just 3 lines.
But
1,
what
2.
about? Okay, I wanted to include by some
Oh,
reason
okay. So
zeta eta is equal to 0, but it is already there.
yeah,
In my calculations, I just um draw the line along 2 and 7, but it's not the right way to do that.
no, cause no node is passing through this, right? So okay, so this will be equal to what? 1 plus eta is 0. This is 0, and 1 minus and xi plus 1. This will give me uh, just a minute. Give me just a minute. I'll join in half an hour. I've been having TA session. I told them अभी नहीं आ रहा है तुम चल रहा है देख कहाँ है कॉल कर लेना कॉल कर लेना sorry for the disturbance. Okay, so we have this. We'll have 1 plus eta, 1 minus eta, 1 minus xi, and this will be 1 1 2. Okay, so this is phi 4. What about phi 8? Can anyone tell me how to find phi 8?
That's a bit to think about.
So we have 1 2 3 4.
Oh, I know. We need to draw a line through eta is equal to -1, a
Okay.
line through the
You're saying
z.
eta equal to -1. Okay, so
Yes. A line
yeah,
through eta -1, zeta -1, and line through the
it,
7 node 7 and so node 5.
come again.
Uh,
I was not able to
eta
get.
-1, line through the eta -1,
Yeah,
and line through the line that comes along 7 node 7 and node this one,
yes, yes.
and
So
this line
is
is
xi
along
uh, xi plus eta equal to 1, isn't it? This line.
is there a fast way to do that? Because I wanted to check. I wanted to find this line as a line that passing through 2 points.
Yeah, 5
I
7.
equation.
Right. Okay. So see, this is having a xi eta coordinate system, right?
Yes.
Xi eta coordinate system. So this origin. If I take this origin, and this line passes with xi line at this point and this point, right? We have an equation of a line,
Yes.
x-intercept and y-intercept,
Yeah. Okay.
y by b equal to 1. So in this case, a is also 1, b is also 1, right?
Okay.
So conclusively,
Okay.
this we are getting. I hope this
Yeah.
makes sense.
Thank you.
Yeah. Okay. So thus, so now phi 8 will be equal to what? This line xi plus 1, eta plus 1, and xi plus eta minus 1. And the coordinate of node 8 is 1 comma 1, right? So this will be 1 plus 1, this will be also 1 plus 1, this will be 1 plus 1 minus 1, right? So this will give me xi plus 1, eta plus 1, and xi plus eta minus 1. This will be 2 to the 4, and so this will be this way. Okay, I hope till here it's clear. So we now have the expression of phi 4 and phi 8. We need phi 4 upon phi 4 upon phi 8, right? So the common terms are this 1 plus xi, 1 plus eta, that can be removed directly. Okay, so finally we'll have as 1 minus eta 1 minus xi by 2 divide by 1 plus xi plus eta minus 1 divided by 4. This can again be simplified and written as phi 4 by phi 8 is equal to 1 minus xi 1 minus 1 minus xi 1 minus eta, again here 1 plus xi plus eta minus 1, and this is 2 divided by 4, then this will give me 2. Okay, so let us see what option matches. So this one, see, 2 times 1 minus xi 1 minus eta 1 plus xi plus eta minus 1, 1 minus xi 1 minus eta, 2 times 1 plus xi plus eta minus 1. Okay, so answer is option D. I hope it's clear now. Can we move on to next question now? Yeah, okay, thanks Rafael. uh, Jess, do you have any doubt, or it's clear for you also? Okay, thanks. Okay, so question number 9, and last couple of questions for today's session. So consider a 4-node element in physical domain and answer the following question. Question number 9 to 10. Consider xi and y are the coordinate of ith node in physical domain, and ci with xi and eta coordinate system is the safe function in parametric domain. And this is the element which we have in the physical domain, xi, yi. So that the question is, the transformation equations are, the options are this, and the next question is, the determinant of Jacobian matrix is. So I'll try to solve for question number 9, and I'll just, using the answer of question number 9, I'll just ask what will be the answer of question 10. Okay, so let's solve this. So it's quite easy thing. So in the parametric domain, what do we have? If I say 1 2 3 4, it has a xi and eta coordinate system. So this is minus 1 comma minus 1. This is 1 comma minus 1, 1 comma 1, and minus 1 comma 1, and this has been mapped to the actual x, I, y, I coordinate system. This is node 1, 2, 3, 4. Yeah, and this is having 0 comma 0. This is 5 comma 0. This is 5 comma 6 and 0 comma 6. This is what is there. Okay, or we can draw the opposite arrow also. So this is in the x y coordinate system. So what will be x in terms of xi and eta, and y in terms of xi and eta? This is what we are asking. Okay. So to solve this, we can see as n1 x1 or phi 1 that will be like taking to a different thing. Okay, so it's best you just see how my x is changing. When I have x value as 0, y xi we are having the value of minus 1, and when we are having x value as 5, we are having xi value as 1, right? And our coordinate system is completely aligned, like xi eta, it's completely aligned. So with this we can directly say, like, see, x equal to uh, so if I say x minus x1 upon x2 minus x1, this is xi minus xi1 and xi2 minus xi1. Okay, so this will be equal to x minus x1. X1 is 0, x2 is 5 minus 0. This is xi minus xi1 is minus 1, and xi2 is 1 minus 1. So this is x by 5. This is xi plus 1 by 2, implies x is equal to 5 by 2 xi plus 5 by 2. So implies x is equal to 2.5 xi plus 2.5. Okay, similarly for y we can see when y is 0, we are having eta as minus 1, and y is 6, we are having eta equal to 1. Okay, so we can write y minus y1, y2 minus y1 equal to eta minus eta 1, eta 2 minus eta 1. This will be equal to y minus 0, y2 6, and this is eta plus 1 and 1 plus 1, implies y is equal to 6 by 2, this will be 3 eta plus 6 by 2, this will be 3. These are the transformation which you are getting. So x is equal to 2.5 xi plus 2.5 and y is equal to 3 eta plus 3, right? So with that we are getting our answer as option C. Okay, I hope please do see that what I have done is when my xy coordinate system is also perfectly aligned with my nodal coordinate system. What I'm saying is uh, if my xy coordinate system would have been like this to my element, then this way we couldn't have find. Okay.
There also will be difficulty that uh, our quadrilateral element can have not only rectangular form.
Yeah, correct. Okay, so I hope you guys don't have to this question. So consequently, what will be my answer to this question? The determinant of Jacobian matrix is, so we have found like x is equal to 2.5 xi plus 2.5 and y is equal to 3 eta plus 3. I would ask others except Rafael to answer before giving. I think Rafael can give the answer quite easily, but I would ask others to give answer first. Okay, so Abdullah has said an answer as option A. Jess, are you there? Uh, you can just say if you are not able to understand, we can have more discussion on this. Yeah, Rafael, now you can give your answer because this, I don't know this is there or not.
My answer is A.
Yeah, yes, the answer is option A. Let's see how it comes. Jacobian is what I'll will have is, see, Jacobian matrix will have dx, dou x by dou xi, dou x by dou eta, dou y by dou xi, dou y by dou eta, right? So this will be, the Jacobian will be equal to, this will be 2.5, this will be 0 0 and this will be equal to 3. So the determinant of this Jacobian matrix will be 2.5 times 3, that will give me 7.5, which is what my answer is. Okay. Okay, now we'll just have a discussion of the assignment solution quickly. So this was the first question of the assignment number 7. Choose the correct option from the following statement. First statement is both displacement and strain are constant within a CST element. Second is a fourth order polynomial can be integrated exactly with 2-point Gauss quadrature, and we have 4 following options. So yeah, so Rafael has said option D. Ah, what about others? Yeah, hmm. I don't know whether this is still here or not. Yes, the answer is option D. As we have already discussed on this regarding 2-point Gauss quadrature rule, 2-point Gauss quadrature can give an exact value del. 3, degree 3, or I would say quadratic, cubic polynomial. So answer is option D. So this was what was there in the assignment, and as we have already solved a similar question, which is like in a more general sense, this question. So if you are able to solve this, you can easily solve this question. Okay, so this is similar one, and this is what similar. Okay, further. Okay, so uh, this is quite similar to what we have discussed, so we'll just wrap it quite quickly to these questions. So what is the shape function of node 5 for given Lagrangian 9 noded Lagrangian element? No, sorry, 8 noded. It's an 8 noded serendipity element. So what will be the shape function of node 5? I think you guys already know the answer to this. To solve this node 5, we can just do this. So these three lines are what we just need to do, or you can just use the substitution, and by using elimination thing also you can find the answer. So we need to find the shape function of node 5, right? So node 5 has the coordinate as 1 comma 0. Let us substitute everywhere. So 1 comma 0, this will give me 0.5. If I substitute, this will give me 1. This will give me this will also give me 1. No 1 2. Okay, this will also give me 1, and this will give me 0. So we have now two candidates for our solution, right? Now we can just take coordinate. We can take the coordinate. This was for like when we substituted 1 comma 0. Let us substitute, let's say substitute 1 comma 1. So for that we should get the value as 0. So for this, when we for this 2 only was checking. So when we substitute 1 comma 1, we'll get 2 into 2 times 4, 4.4. Here we'll get 2, and here 1 to 1, and this is 0. So our correct answer will be option C, right? Okay, so let's move on. Question number 19. Consider 4 node element for which xi, yi coordinate systems and it are the coordinate system of physical domain and parametric domain respectively. We have the transformation equation as this. What is the value of Jacobian? So as we have solved earlier, similarly the Jacobian will be equal to uh, mm, the matrix determinant for this will be 4.500, and this will be 6.3 equal to 4.5 times 6.3. So this will be equal to 4.5. So this will be equal to 28.35. So answer is option D. Now last question for today's session. Question is, suppose n2 and n5 are the shape function for node 2 and node 5 respectively for given element. What is the value of n2 times n5, where n2 and n5 is the multiplication of shape function at node 2 and node 5? So please see that this is a Lagrangian element, 9 noded Lagrangian element, and we have to find n2 times n5. So I hope you guys don't have any doubt how we'll get the value of n2 is this, right? And n2 n2 will for n2 we'll just use these lines, right? And for n5 we'll use these lines, right? Let's do this quite quickly for n2. So n2 would be having xi plus 1, xi minus 1, eta, and eta minus 1 upon node 2 has a coordinate value of 0 comma having minus 1. So this will be equal to 0, this will be 1 times this will be minus 1, eta this will be minus 1, and this will be equal to minus 2. So n2 is equal to xi plus 1 xi minus 1, that is xi square minus 1, and this is eta square minus eta, and down we have 2 minus 2. So to make it more positive sense, we can just write 1 minus xi square, and this is xi square minus eta square minus eta, and this is 2. Okay, and n5 for n5 we'll use these lines, right? So these are equal to uh, xi plus 1 xi minus 1 eta plus 1 eta minus 1, and all at the values xi and eta have values of 0 0. So this is 1 times minus 1, this is 1 times minus 1, so this is just equal to you can just write it more simplified way. So this is 1 minus I square 1 minus eta square. Okay, now n2 times n5 would be what? We have 1 minus I square is common, this will be equal, then 1 minus eta square and eta square minus eta upon 2. Okay, so let's see what is my correct option. 1 minus I square whole square, 1 minus eta square minus eta 0.5. So this is my answer, option B. Okay, I think this is it. We'll close our session here now. I hope nobody has doubt to our today's discussion. Okay, Rafael wants to ask something.
I wanted to ask not about current session, but about you said in the beginning that you will share the code
No,
somewhere.
no, I said that we discussed the code in the previous session.
Okay,
We
but
worked
I am
we
not.
we worked it out, right?
Yes, yes. But as I noticed when you open your MATLAB, the code was there. So you have rewrite it after our discussion or what?
No, no, no. I just worked it out on the same thing. I you actually corrected those things in your system. I did myself the same thing. And
Okay, okay.
okay.
Interestingly, that mm, there on the 8th week we have a computer implementation of a temperature problem, but there's no code shared.
I don't know. Let me see. Can you share the screen yourself?
Okay. Can you see my screen?
Yeah.
This is a computer implementation
Week
called
8.
Wikid,
Yeah, you have clicked
but
on the. Okay. Yeah.
there is no code share. You just see here computer implementation, but there's no code.
I have not gone through, but there might be that the previous codes which was shared that might be in use. Actually,
Okay.
it's discussed in the lecture, so you can actually go through it as
Uh-huh.
well.
Okay. Okay. I will try.
Yeah. Okay. Have to go actually,
Uh,
so I want to end the session here now.
okay. Sorry. I believe the next session will be
In the
interesting if we will want to
yeah, yeah, yeah.
discuss again code
Code
stuff.
related. Yeah, yeah. Sure, sure. Okay.
Okay. Thank
So
you for the session.
yeah, thanks. Okay, we'll end the session. If you guys
Bye.
don't have any doubt, okay. Bye. Take care. We'll meet in the next weekend. Bye. Take care.
Have a nice weekend.
Yeah. Okay. Bye.